Good morning, class. Welcome to our first online lessons, and we are first going to look at quadratic sequences. Now, what is a quadratic sequence? You did it last year, and you can remember that a quadratic sequence has a second difference, which is constant. Let me show you again what that means. If we take this sequence and we want to get our first difference, we minus the second term and the first term. So it's term 2 minus term 1. To get the second one, you say term 3 minus term 2. You always say the next term minus the previous term. And this will give us 5 minus 0 is 5, 14 minus 5 is 9, and 27 minus 14 is 13. This is our first difference. To get the second difference, we follow the same pattern. We say 9 minus 5 is 4, and 13 minus 9 is 4. This will give us our second difference. Now you can see that the second differences are all the same, and that is where we say the second difference is constant. They don't change. We use 4 formulas in the quadratic sequence to answer all our questions. Here is a summary of all of them, and I will show you where they come from and how to use them. Our general term is this one. Our second difference, we use this formula. For our first difference, we use this formula, and to get term 1, we use that formula. Now, where do these formulas come from? We first substitute 1, 2, and 3 into n every time, and we use our general term. So to get term 1, I'm going to write a, and I'm substituting 1 into n. So it's 1 squared plus b times 1 plus c, and that will give me a plus b plus c. To get term 2, I substitute 2 into n, so it will be b times 2 plus c, and we get 4a plus 2b plus c. To get our third term, I substitute 3 into n, and I get a 3 squared plus b 3 plus c. Therefore, it will be 9a plus 3b plus c. Now we are going to get our first difference. Remember, I told you it will be term 2 minus term 1. So term 2 will be 4a plus 2b plus c minus term 1, which is a plus b plus c. Can you remember from grade 8 that when you have a sign in front of a bracket, you always have to multiply the sign with all 3 terms? So a minus times a plus will give you a minus. A minus times a plus will give you a minus, and a minus times a plus will give you a minus. Then we are going to use the pink ones. 4a minus a gives you 3a. 2b minus b gives you 1b. c minus c gives you 0. Let's do this method here again. So it's 9a plus 3b plus c minus term 2, which is 4a plus 2b plus c. Again, we have to multiply the sign into every term. A minus times a plus is a minus. A minus times a plus is a minus, and a minus times a plus is a minus, and we're not going to use those. So 9a minus 4a is 5a. 3b minus 2b gives me 1b. c minus c is 0. Again, we're going to get the difference between these two terms. So it's the next term minus the previous term. 5a plus b minus 3a plus b. We multiply the sign with each term. A minus times a plus is a minus. A minus times a plus is a minus. 5a minus 3a gives me 2a. b minus b gives me 0. So, in this case, this will be my second difference. This will be my first difference, and this will be term 1. And that is the same as these three formulas. So that's where they come from. Let's look at an example. Here we have a sequence 3, 9, 19 and 33. The first type of question that we can ask you is, which type of sequence is this? In order to determine that, you first need to get the differences. So let's do that first. 9 minus 3 gives me 6. 19 minus 9 gives me 10. 33 minus 19 gives you 14. And we do that again. 10 minus 6 gives you 4. 14 minus 10 gives you 4. And we see that our second differences are constant. Therefore, this is a quadratic sequence. And you write the second differences are constant. Therefore, it is a quadratic sequence. The word constant must appear in your answer. Let's look at a next question. What is the general term? Okay. The general term, we need those 4 formulas. Now we know that this one, the second difference, equals to 2a. And we know that the first difference equals to 3a plus b. And we also know that our term 1 equals to a plus b plus c. We always start at the bottom. To determine a, then substitute a into that formula to get b. And then substitute a and b in the first formula to get c. And once we have a, b and c, we substitute that into the general term to get the general term. So let's do them first. 2a equals 4. We divide by 2 and we get that a equals 2. Now we're going to use our next formula. 3a plus b equals 6. We know that a is 2, so we can substitute it in there. 6 plus b equals 6. If we take the 6 over the equal sign, it becomes minus 6. So b will be 6 minus 6, and b is therefore 0. Now we use the last formula. A plus b plus c equals 3. We substitute the a with 2, the b with 0, and we work out c. 2 plus 0 is 2, so 2 plus c equals 3. We take the 2 over the equal sign, it becomes minus 2. So c equals 3 minus 2 is 1. And therefore we can now determine our general term. A is 2, so it will be 2n squared. B is 0, so it will be 0n. And C is 1. 0n means nothing, so it will be 2n squared plus 1. And that is my general term for this sequence. The next question that I can ask you is to calculate, let's say, the 100th term. Therefore, we want to know what is the value of T100. That is actually very easy. The 100 stands in the place of n. So n is 100. We use our general term to calculate this answer. Our general term is 2n squared plus 1. If n is 100, we can substitute it into n's place. So T100 will be 2 times 100 squared plus 1. That will give me 2 times 10,000 plus 1. And that gives me 20,000 plus 1, which is 20,001. I can also ask you which term has a value of 51. And I actually ask you, what is n when the value is 51? This means I want Tn equals 51. What is n's value? Again, I use the general term. Tn equals 2n squared plus 1. I know that Tn is 51, so I'm going to place the 51 into Tn's place. 51 equals 2n squared plus 1. Now I must solve n, so I can see it's a quadratic formula. I take the 51 over the equal sign, and I get 2n squared plus 1 minus 51 will give me minus 50. I can now divide by 2 on all the terms. So 0 divided by 2 is still 0. 2n squared divided by 2 is n squared minus 25. This is the difference of squares. So I get two brackets, n minus 5 and n plus 5. So I get a value of n equals 5 or n equals minus 5. But n is the place value of a certain term, and we can't get a minus fifth place. You can only get a fifth place, so the negative is not applicable. And I get that term 5 will have the value of 51. You could also have worked it out with your sequence by remembering that the second difference is always constant. So I have a 4 here at the bottom as well, and I'm going to work up. So 4, how do I get this value? 6 plus 4 gives me 10. 10 plus 4 gives me 14. 14 plus 4 gives me 18. And now I do the second sum. 3 plus 6 gives me 9. 9 plus 10 is 19. Therefore, 33 plus 18 will give me 51. And that is term number 1, 2, 3, 4, 5. So term number 5 is 51.